Now we want to show an example of resolution based on the following problem. So see, there are 5 sentences in the knowledge base, okay? So and then we want to convert them. Step 1 is convert them in CNF form, okay? Convert knowledge base into CNF form. CNF form is the conjunctive normal form. Let's say A or B or C. This is one clause where the literals are in or connected. Okay, so this is or disjunction. And then the clauses are and connected. Let's say D or E. So this is a CNF form. Okay, so this is a CNF form, conjunctive normal form. So now first step is that convert those sentences KB1, KB2 into the CNF form. How we do that? Let's say KB1 is what? This is A or B and C implies E. Okay, so this thing is equivalent to, we have to apply those different inference rules. So what we can apply, first we will apply the implication elimination. So this rule, so alpha implies beta is equivalent to not alpha or beta. So this will become not of, so alpha is this side, so that's A or B and C or E. So after applying implication elimination, okay, so this one we applied. Then the next step will be, opening that, including that negation inside. So when we include that inside the parenthesis, so this is not of alpha. So let's say this is now alpha, this part is now alpha, and then this is and this part is beta. So this is not alpha and beta. This one, De Morgan. Okay, so we'll apply De Morgan law and say it will become not alpha or not beta. So this will become not alpha, which is A or B, and or not beta. Okay, or not beta, not C, that means. And this whole thing will be within parentheses, and there'll be or E. So this is De Morgan's law. I'm just writing De Morgan. Okay, then after that, this is equivalent to not of alpha or beta. Can then we apply this one directly, not of alpha or beta, A or B. So this one will become, so that means negation will come again inside. So that will be not A and not B. And then we have or not C, and then we have or E. So after this, we will apply distributivity, okay, over, so this one, alpha or beta and gamma. So this is basically alpha or beta and alpha or gamma. So not A or not C and not B or not C. So, and this thing again, not E. So this is distributive. So we applied distributivity. Okay, so now we can apply distributivity once again. So like this is now alpha this is the entire thing is beta, right? So this is alpha and beta, or so this is again basically the same rule we are applying. So same rule we are applying. Let's go down a little bit, and we will have here, so this is nothing but not A or not C or E, and not A, not B or not C or E. Okay, so this is also the same distributivity. So now we have two clauses. Now by simplification or and elimination, we can say individually both are true. So this clause is, I think, not here, but this is alpha and beta both are true because it's an and connected, so individually they are true. So we call the first one as clause. So let's say this one we name as clause C1, and this one we name it clause C2. So KB1 divides to two clauses. So this is one is C1 and the other is C2. Now let's see the second knowledge base sentence, which is D or F implies A. Okay, KB2, D or F. So KB2 says D or F implies to D and F implies A. So this will change. So D and F implies A. So this is like D and F implies A. Now we first apply implication elimination. Okay, so implication elimination gives us what? It gives us D not D and F or A. So that's exactly implication elimination says. If you can see that here, alpha implies beta. So implication elimination says not alpha or beta. So you see, that's exactly what we did. Now this is equivalent to, I'm just writing this side just to save space. So this is, now we have to use De Morgan's law, not D and F, which is De Morgan's law here. Not alpha and beta is not alpha or not beta. So that's by De Morgan. So I think I need to write here that implication elimination, right? Implication elimination. Okay, so I'll follow here De Morgan. So that will be not D or not F, okay, or A. So now we apply distributivity of or, distributivity. Then this will give me two more clauses, not D. No, it's just one clause, not distributivity. So this is this or A. Okay, so this is not distributivity. This is just opening the parenthesis, you can say that. Okay, so this is a clause, let's say C3. So let's say this one is C3. Okay, so from KB2 we get C3. Now let's see what we have KB3. KB3 will have not E or D. That's already in CNF form, not E or D. KB3 gives us not E or D. So that means KB3 gives us not E or D, which is already in CNF. Okay, so that we call as a clause C4. and then we will see what's the next one. Next one is KB4, which has clause B and C. Okay, B and C. KB4 gives you B and C. So from this we can get two clauses because by AND elimination. So this is basically equivalent to saying B, C separately. Okay, so by AND elimination, AND elimination or simplification. This is also called simplification because they are AND, they are, if they are true individually they have to be true. So I call them, let's say C5 and this one as C6. Okay, six clauses already I got. So now I have one last clause which is KB5, which is just F. So KB5 is F. Let's say KB5 is F, and that's the last clause, which is C7, right? So now I have 7 clauses. 1, 2, 3, 4, 5, 6, 7. So now what we do, so here I can write from KB4 I got 2 clauses, C5 and C6. Okay, so now you see what we can do. We have to see how we can combine the clauses and cancel the complementary literals. So let's see, can we do C1 and C4? Why we choose C1 and C4? Like C1 has not A, not C and E, and C4 has a not E. So E and not E will cancel out. Okay, C1 and C4. Let's take a different color, and let's say I take purple and resolve C1 with C4. Okay. Okay, so here one thing I missed, so which is the second step of the resolution says that we have to prove something. So you see, prove A. So if you remember, resolution works by contradiction. Okay, so we have to prove the knowledge based sentences, prove A. So that means we have to AND with knowledge base and not A. So now we have all the 7 clauses. So this is basically becoming C1 and C2 and C3 and C4 and C5 and C6 and C7 and not A, which we can call C8. Okay, so now then we have to show that after resolving this we will get a null clause, and then if we get a null clause we can say that, oh, not A is false, that means A is true, that means KB entails A. So it's a proof by contradiction, remember. So now let's start resolving the first step, C1 with C4. If you don't remember what was C1, let's see, not A, or not C or E. Okay, so with this C4 is what? C4 is not E or D. When you resolve this to E and not E will be cancelled, so what we will produce is not A or not C or D. Okay, so we call it R1, resolvent 1. Okay, so now with R1, let's see if C6 can be used. C6 has a C, and see this has a not C. So so now this is, let's say, the step 1. So step 2 is resolve R1 with C6, which is just a C. So what will be the resolvent? The resolvent will be not A or D, because the not C will cancel out with C. Okay, so let's call it R2, resolvent 2. Okay, so now what we need to do, the next step, we can try to do C3 and R2. So this R2 we resolve with C3. Why? Because this has a not A and a D, and then C3 has a not D and a A. That is exactly opposite literals. So let's say step 3 is when resolve R2 with C3. Okay, C3. And then what we get is not A cancels with A, D cancels with not D, so remains is not F. Sorry, just F. Oh no, not F. It was okay. There's a not F here, right? So not F. And then, so this is our R3, resolve 3. Now we can do the number 4, step 4. What we do? Our last clause KB5 is F, which is C7. F and not F resolves, cancels out, complementary to each other. So resolve R3 with C7, and then we get a null clause. Getting a null clause means what our proposition was, that is false, and that means not A is false, that means A is true. Okay, A is true. So if A is true, that means from the knowledge base we are generating this. So KB entails A, because the definition of entailment is that whatever we derive from there must be true. So that's soundness, and so this we proved KB entails A.